Hi, Assalamualaikum. My name is Simpaka Luratila Bitus Rizam, your matrix AF190109. Okay, I will talk about the introduction. First of all, I will introduce the definition of concrete work, which is based on basic civil engineering. The meaning of concrete is the compound material made up of cement, coarse aggregate, and water. These are the main compound of materials of the concrete. After that, it will form the cement paste. After that, the compounds will form the concrete mix, and it will transfer into molds and get a specific shape desired. Sometimes the cement paste will get hardened, and we will do the compaction. Basically, concrete work includes the following basic process, which is the preparation of the concrete mix, the delivery, the curing, and the compaction of the concrete formwork. Next is objective. Number 1 is to give the advanced knowledge about the safety, health, and occupational in real life as civil engineer. And number 2 is to identify the hazards and the risks during concrete work in construction activities. And then number 3 is to recommend the suitable risk control for the concrete work hazards.
Assalamualaikum warahmatullahi wabarakatuh. I'm Amira Haduna binti Najri, Mathematics CF190204. Okay, today I'm going to explain the flowchart of this project. So this flowchart is developed for the construction, execution of form, reinforcement and concrete works for the development of 20 units of a 5-story lecture room building at Institut Hussein of Malaysia. So as you can see in the slide, this is our flow of work that we're going to use in this project. So the first, we're going to install the formwork, followed by install the reinforcement, and then we proceed with concreting, and then finishes and followed by the curing, and lastly we're going to remove the formwork. So I'm going to explain deeper about the methodology for this flowchart. So I'm divided into the 3 parts. For the first part is formwork. I'm going to explain the fabrication, installation and removal of formwork, and the second part is reinforcement, how to install the reinforcement, and lastly concreting, where I'm going to explain the procedure before pouring, during, and finishes also curing. So the first one is fabrication formwork. So we must make sure that the formwork is clean, strong and clear from any substance, and then we will build the formwork based on the dimension correctly, and then lastly using shutter by steel bars to maintain the proper alignment of the form. So the second part is installation formwork. So first we must make sure no foreign material and the formwork is leak proof, and then we verify lines, levels and measurement before proceeding with installation formwork, and then we apply waterproof sealer on the formwork, and then the temporary opening shall be provided for inspection and for removal of water, and shall be sealed before placing concrete. Next, the contractor shall clear out block out item for concreting, and then pipes and pipe spatial through concrete walls shall be positioned correctly where not practicable to cast pipes and spatials in concrete box holes, and shall be formed in the shuttering. And lastly, the remaining hole around the pipe or the holes with the formwork support shall be filled with non-shrinks epoxy growth or non-shrink concrete. So lastly, removal formwork. So the formwork shall not be stroked or stripped unless concrete has attained enough strength to withstand operation load and surf weight, and then remove form starting at the top of sloping. Use a hammer to remove nails from the stakes holding the form in place. The formwork shall be carefully stripped to avoid sudden shock from the removal of which or vibration which might cause damage to the concrete. And lastly, reshoring to beams and slab should be placed immediately after stripping formwork. So we're going through the second part, which is reinforcement. So the reinforcement should be clean and free from any substance adversely affecting reinforcement, concrete or bond between the two. Rebar should be protected with polyethylene sheets, and then we prepare the cutting and bending of reinforcement, which shall be in accordance to drawing. Next, fabrication of reinforcement may be done on site or in the fabrication shop, which it depends on the situation, where assembling of reinforcement cage should be done on site. So next, reinforcement installation in any part of the reinforcement concrete structure should be securely and accurately fixed in the position shown in the drawing to ensure that the reinforcement steel framework as a whole shows retain its shapes. And then the contractor shall put spacer, chairs and other support um, as necessary to maintain the reinforcement in the correct concrete covered reinforcement. Next, the ends of all tying wires should be turned into the main body of the concrete and not allowed to project towards the surface. And lastly, working on reinforcement for access purposes will be avoided where possible. Where it is unavoidable, any deformation will be removed or repaired prior to concreting. And lastly, we're going through a concreting work. So the first one is preparation before pouring. The reinforcement should be sprayed with a small amount of water before starting the pour. Then water will be removed from excavation before concrete is deposited. Lastly, for night concreting works, the contractor should arrange adequate suitable lighting. So the secondly is placing of concrete, where the concrete should be placed continuously up to or between construction joint while it is still sufficiently plastic for adequate compaction. Lastly, after placing, the concrete will be consolidated by using mechanical or electrical vibrator, which will be operated by competent workmen. So the third work in concreting is finishes, where the finishes is a process that strives to create a smooth, durable surface. When finishes, concrete timing is crucial and must be alert to the condition of the concrete. Improper finishing techniques can lead to weak, damaged, or unattractive slab. The method for finishes work is use a square, shovel or any tools to push and pull the wet concrete into place, and then remove the excess concrete and bring the surface of the concrete to proper grade using a strip, board or special tool called a screed. And then use a derby or bull fluid to level ridge, fill voids and slightly embed the aggregate, then allow the bleed water to disappear. Once all the water is gone, create neatly rounded edges along the perimeter of the slab using an edger. Prevent unwanted cracks by jointing the slab with grooving tools. For smooth hardened surface, use a steel trowel or Fresno to trowel the surface. So as you can see, right bottom on the left, where the finishes using trowel, and the second one is using salt finishes, and the third one is stamp, and lastly is broom finishes. So the last concreting work is curing. So the curing is the process in which the concrete is protected from loss of moisture and kept within a reasonable temperature range. The result of this process is increasing the strength and decreasing the permeability. In addition, curing also the vital role in mitigation cracks in the concrete, which severely impact the durability. The process started immediately after pouring the concrete. So first step is pouring or continuously sprinkling of water on the concrete. Application of Hessian cap continuously wet and covered with white polyethylene sheets. And lastly, application of waterproof sheet material subject to approval by client.
Hi, Assalamualaikum. My name is Nuruz Naminti Suadin. My method number is CF190223. Today, I would like to present about risk assessment. First, we go to the risk assessment process. Firstly, we must classify the activity, then identify the hazard, then determine the risk, then decide if the risk is tolerable, and lastly, take risk control action plan. Classify activity. Classify work activity is information on the facilities, processes, and organization activities, such as area map, geographical area, routine analytic activities, stage production or service process, toxicology and other health data, or inventory of material. Next, identify hazard. Identify hazard is to highlight the critical operation of tasks, that is those tasks that posing significant risk to health and safety of employees, as well as highlighting those hazards pertaining to the certain equipment due to the energy sources, working condition or activity performed. Types of hazard is chemical hazard, physical hazard, biological hazard, ergonomical hazard, mechanical hazard, electrical hazard, fire or flammability or explosion hazard. Next is risk assessment. Risk is a measurement to analyze and evaluate hazard. In mathematical terms, risk is likelihood times severity. What is likelihood? Likelihood is an event likely to occur within a specific period or in a specified circumstance. Severity is the outcome of an event such as the severity of injury or health of the people or the damage to the property or insult to the environment or any combination of those. This is HIRAC guideline for likelihood table. Why is HIRAC guideline for severity table? This is qualitative risk table with very likely is frequently happen and highly unlikely is could happen but probably not happen. This is semi-quantitative risk assessment with likelihood is 4 is daily while 1 is yearly. For the severity is 4 is fatality and permanent disability while 1 is for 8 and near miss. Next is risk metric. Risk metric is used to define whether the hazard is tolerable or intolerable. This is risk metric table with the red one is high, which is intolerable, and the low one is green, which is tolerable. Next is risk control. Risk control is the elimination or inactivation of the hazard so that the hazard does not pose the risk to the workers. The hazard must be controlled at the source where the problem is created. This is risk control table by HIRAC guideline. Next is hierarchy control, with the most preferred method is elimination, then substitution, and then engineering control, and then administrative control, and the last resort is personal protective equipment.
Assalamualaikum and hi, I am Aina Ajobedi alias CF190238. I present HIRAC table. HIRAC table consists of hazard identification, risk analysis, and risk control. The recognition of things that may cause danger or harm to a person is known as hazard identification. The examination of the probability of injury or harm to a person if exposed to a hazard is known as risk assessment. Next, risk control refers to safety procedure that remove or limit the likelihood of a person being exposed to a hazard. Our company name is Maju Bersama Construction Sdn Berhad. We are doing concrete work and finishing. We have listed the possible hazard that may have highly chance to occur. This hazard is identified, then the risk is analysed and provided with control measure. The first activity is working at height. Potential hazard, fall and collapse. Risk, bone fracture. Source of hazard, inadequate safety measures. Risk analysis, severity, major injuries and fatality. Risk control, managers and supervisors must provide fault arrest equipment. Next is mixing concrete. Potential hazard, the hands of worker exposed to fine dust of cement. Risk, the hand become irritated and irradiant. Control measure, use of protective gloves and boots. Provide sufficient personal protective equipment. Severity, minor injuries. The third is cabling operating. Potential hazard, the worker breathes without a protective mask. Risk, breathing problem due to silicosis. Control measure is limit the amount of silica dust. Next, provide sufficient personal protective equipment. Severity, minor injuries. Fourth is plastering work. Potential hazard, standing for a long time during plastering work. Risk, back pain. Severity, major injuries. Control measure, take time to rest before continuing plastering. Consult with a occupational physician about proper ways of doing the work. Fifth is feeding of mixed concrete. Potential hazard, wet concrete splashes into the eye and skin. Risk, irritation to the skin and eyes. Severity, minor injuries. Control measure, wear eye protection with side shields or safety goggles, or use waterproof knee pads or a dry board when kneeling to place or finish concrete. Next is delivering concrete mix to site. Potential hazard, truck collide. Risk, body injuries. Severity, major injuries. Control measure, change speed or direction that will lessen the impact. Next, vibrator and operating concrete. Potential hazard, noise from the operating machinery. Risk, hearing damage from continuous noise over a long period. Severity, major injuries. Control measure, using quieter machine and using effective protective equipment. Next activity is shoveling. Potential hazard, manual handling. Risk, sprains, strains and fractures. Severity, major injuries. Control measure, workers need time to rest. Need more workers to shovel another worker's spot. Last but not least is sealing concrete or curling. Potential hazard, spray, sealing compound. Risk, skin rashes or allergies. Severity, minor injuries.
Countermeasure, wear appropriate PPE, such as tall rubber boots, and wear eye protection with side shields. And last is surface finishing. Potential hazard spray finishing operation. Risk fire and explosion if used in large quantities or in enclosed area. Severity, major injuries and fatalities. Countermeasure, employers shall provide employees with effective information and training on hazardous chemicals and provide adequate local exhaust ventilation for all coating processes. This third hazard is a potential hazard that may occur in the concrete work and finishing.
Hello, my name is Nurizati binti Zabidi, metric number CF190.7. I will talk about conclusion. Workers' exposure to this risk varies throughout the course of their lifetimes, and it varies across and within occupation and industry as well. Therefore, it is important to have accurate information on this health and safety hazard when doing analysis that aim to explain life course health outcomes, or that use health characteristics as variables to assist explain significant life course transition like retirement. Employers should commit to safety and health practice and should abide by all occupational safety and health (OSH) requirements in order to lower the risk of hazard, especially the most critical ones. Give workplace safety and health rules first priority and uphold them. Additionally, mission risk has been highlighted as the most important safety and health risk associated with engineering process. Maintenance is one of the factors that should be taken into account. It will have a risk management solution to control this risk, which is software for scheduling. Last but not least, workplace safety is crucial and is everyone's responsibility: the government, the employer, and the worker. Any safety and health program requires participation from the organization, management, and employees, as well as full collaboration when it comes to safety and health concerns. That's all from us. Thank you.